Hello everyone. Very memorizing evening to everyone. This is Piyush Kashyap, a technology enthusiastic and UI UX developer, currently working as a core team member and event organizer at EngineersConnect. I would like to welcome you all to this pleasant evening. We all are here to participate in the webinar Prosthetics and New Generation Computer Vision. We plan to conduct this event for motivating and skill enhancement of individual to build a new thought for each and every mindset. At the end of this session, I hope this will be going to be a successful event. So thank you very much for your participation in advance. Now, I would like to introduce our company, Engineers Connect. Engineers Connect aims at building a new ecosystem for engineers and tech aspirants where only their skills matter, opening doors to a vast community, knowledge building, and employment opportunities. Explore to find jobs and internships, guidance and clarifying doubts to engineers, providing free online tests in EC portal to know whether students has relevant knowledge about the stream, and it also increases EC points and increases your chance to fetch jobs and internships. We are giving webinars, workshops, and courses for engineers to have their core concepts on particular subjects. Now, with due respect, I would like to introduce our expert, Anustop Mukherjee. He is presently a student developer at Google TensorFlow GSOC, former computer vision engineer at Dark House, Silicon Valley, USA, former lead AI engineer at Omanda, USA, winter intern IIT Patna, worked at 6 plus companies with 2.5 years of experience in AI development, holding patents, research and publications, training 2K plus students in AI, spoken at 30 plus national and international conferences including PyCon, BellPy, HowardX, MIT TechX, and much more. I would like to request all the participants to follow each and every guideline given by him. We focus in the whole session and don't leave the meeting in between, as all your queries will be resolved at the end. Thank you. Over to you, Anustup Mukherjee. Dice is all yours. Thank you.
Yeah, thank you so much for the warm introduction and a warm welcome. So, hello everyone. I'm Anustup. So, today our main topic of the discussion will be new generation computer vision and with the light of the prosthetics. As you all know, like prosthetics is something that is related with the hardware dev and hardware related solutions that is being provided from the side of the AI ML or the core robotics side. So, thank you so much for the warm welcome. Let me share my screen. Yeah. Let me know if my screen is visible. Right? My screen is visible properly.
This,
Is
this.
my yeah, okay. So yeah. So today's topic of the discussion is computer vision and the prosthetics, as you can see in the screen. So yeah. So what comes in our mind when we speak about computer vision, or what comes in our mind when we speak about prosthetics, is something that is coming with some supernatural ideas. So whenever we hear about the term called as computer vision, we always come across the stuff like, okay, when the computers can see and when the computers can have a human like attribute like of seeing the stuffs, analyzing the stuffs at the back end, right? So this is a very basic level understanding about computer vision. And when we are hear about the term prosthetics, so like if you ask an artist like what do you mean by prosthetics, and the artist will be telling like simply mimicking the body structure of a person. Like if you go to a prosthetic artist will be generating some kind of a face mimicking mask like your face. That means he will be completely generating a mask that is completely similar to your face. Either he will be simply generating a body suit that will be completing fitted with your body structures. That means completely mimicking the human external architecture and creating that kind of a structure or that kind of a stuff comes under the term called as the prosthetics. Now, in the present day, in the developing world of AI, since you all know AI is the buzz in industry, and we are dealing actually all minute problems of the world with the power of artificial intelligence. So, in the present day AI, when we have a lot of problems in front of our eyes, so computer vision and the prosthetics together is coming into the actual real implementation. It is actually a part of the robotics and implied with the computer vision. So without wasting in time, let's get proceeded. So already Piyush introduced me. So this is a very brief about me. Anyone can connect with me on my LinkedIn, Twitter, or GitHub. So right now I'm presently working on the computer vision algorithms of TensorFlow Google under GSOC. Apart from this, I had worked. My main expertise domain is CV actually. So today we will be simply have a quick introduction on the topics. We will be seeing actually what are those kind of the problems that the industry is actually facing. That means we'll be addressing that stuffs in which actually the computer vision and prosthetics can handle. Yeah, obviously every technology have some kind of applications and some kind of limitations, right? So specifically we will be only focusing on the application areas by understanding the problem, so that you guys, since you guys all are the beginners, you guys can also create this kind of the examples in your real life, both software and both from the hardware end. We will come across some kind of basic definitions. We will see the Python's involvement, like how can you code that kind of amazing stuffs in Python. We will be seeing some kind of real day applications, some kind of real day solutions and their architectures, and also some kind of the PyCodes. And finally, we will be dropping into a conclusion and ending our the session. So yeah, so first thing that comes, like what is computer vision? So here in the meme that is being presented in the screen, you can see a computer is simply speaking to a lady, and a lady is actually eating a lot and lot and lot, and a computer can easily understand that particular lady is already obsessed or already obese, right? So specifically the lady is already obese, already fatty so much, and now again the lady is eating a lot of foods. That means it might be harmful to her health. So the computer is simply speaking, hey, don't eat so much, you are already a lot fatty, right? So how can a computer can understand someone or something that is sitting in front of it, like its body structures or its ideology or how the person looks? How can it be possible? This technology is called as computer vision. Like this is a part of artificial intelligence, that gives some kind of a visual attributes to the machines or a visual attributes to the particular structures. That means in a single language or a single line, if you want to understand like what do you mean by computer vision, then you have to simply look at your face. What does your face do? Your face, like simply like your eyes used to see the object. Your eyes is having internally optic nerves, right? What does this optic nerves is doing? Your optic nerves is simply taking the data and carrying the data into your brain, right? And what your brain is doing, your brain is simply processing the data and coming up to a conclusion. Okay, whether I'm seeing a laptop in front of me or whether I'm seeing some kind of chair in front of me. So that kind of the detections, that kind of recognitions is being carried out through the brain, and that thing is driven, and you speak through your mouth. Okay, this is a chair, this is not a laptop, right? So the same phenomenon happens with a computer by the power called as the computer vision. So this is actually all about the field about which we are actually talking right now. So there is some kind of examples when we speak about computer vision, because before going into deep tech stuffs or understanding some kind of an applications, we have to always understand the field examples. So specifically computer vision is that part of AI that speaks about the real day scenario. Any kind of the image and a video can be processed by a single technology called as a computer vision. It simply speaks about the thing that you see in front of your eye, whether it is an image or whether it is a video. That's all about computer vision. So in a simple example, here you can see a Spider-Man is traveling from one building to another building, right? So if for an example, at a moment, let Spider-Man's brain is processing computer vision, then what are the decisions, or what kind of algorithm the Spider-Man will follow? So initially when the Spider-Man is sitting at the top of a building and he want to jump to the next building, at a very first moment, the Spider-Man's brain have to understand like whether any kind of obstacle or whether any kind of obstruction being present in front of my eyes or not, right? So whenever we want to detect anything that is present in front of me, the anything in the real day or in a real life is called as an object. Something that holds some kind of mass, some kind of space is termed as an object. That's it. So the algorithm, the part of the computer vision the Spider-Man brain will imply is called as object detection. Simply, it will be detecting the objects and it will be carrying out the stuff. That means it will understand whether in front of me there is a clear sky or there is a tall building that might obstruct my path. That's it. Now, at a very second moment, just for an example, the Spider-Man is simply seeing out. The Spider-Man is simply seeing out. Okay, okay, I have detected the objects. Now I want to understand the name of the objects. That means you are having a food in front of your eyes. A food might be of any part or might be of any type. A food might be of any type. That means whether it is a veg, whether it is a non-veg, whether it is something else. But what it is the specificity of that particular food? You are a human. When a computer vision will follow object detection, he will only tell you as a human. It will not tell you with your name. But when you want computer vision to tell you with your name, then you have to come to the next application of CV, that is called as the recognition, that is called as the object recognition, right? So it specifically gives out the data, that means which type of an object that is being present on it. The third most important part when we speak all over about the CV is called segmentation. So in a segmentation, what happens actually is like you, for just for an example, 4 people are living in a single hostel room. And obviously, all the stuffs that is present within that room will not be yours. Some might be your friends and some might be yours, right? So specifically on that particular case, you have to understand which part of the stuff is mine and which part of the stuff is not mine, right? So when there is such kind of discriminations, that means this part is mine and this part is not mine. That technique is called as a segmentation. And apart from this, the last two parts is called tracking and selection. So tracking, we all know that is following someone or something or somebody, right? So tracking is actually having a heck lot of applications. Whenever we want to track any kind of football or track any kind of sports or track any kind of object, it is simply trying to understand. Just for an example, if the Spider-Man is applying the tracking algorithm, then it will be simply tracking the path. That means from where to where I am actually traveling. So this is one of the biggest application of computer vision. So coming to the next part, that is like the problem in the ongoing industry. Now, before coming to the problem, we have to know about the applications. That means, see, right now we are living in 21st century, and like AI is already a lot of boom right now, right? AI is actually in a lot of fields like generating image, understanding image, analyzing image, taking an inference out of it. A lot of things is being done by AI already, right? But still, just for speaking some kind of specific examples for computer vision, computer vision is actually right now creating a boom in our industry, of the sports, right? So what is happening in the sports? Just speaking about the last company I have worked on, Dark Horse. So Dark Horse in a setting in Silicon Valley, they were trying to create a complete AI operating OS, which is an operating system that will simply see a real-time video match or a real-time football match, and it will analyze the each and individual stuffs or each and individual statistics of a football player. That means it will simply give you in a result that how much game the Messi have played, how much goals Messi did, how much goals Neymar did, how much passes they have played. The entire statistics will be extracted and being simply holded on in front of your eyes, right? So this architecture we already worked on. So it is having a lot of things in the sport industry, like not only the football, as well in the cricket. Just when you see IPL, you can see when a simple umpire calls like a review decision, right? So in that particular case, what happens, you can see that every small points of the ball that is being traveled out of the boundary, inside boundary, over the stump, before the stump, everything in a particular slow motion, right? In a particular slow motion. So in a slow motion or something like in a tracking mechanism, everything is being properly guided and being visualized. That's also an application of CV. Apart from keeping aside the sports industry, CV have a huge application when we speak about our medical industry, actually health IT. So specifically, I also own a health tech startup, MBK. So specifically, we are also utilizing the CV architectures in creating and detecting cardiac arrests and cardiac blockages. Actually, mostly in cardiac applications, or what the thing I'm doing at my startup, we are actually analyzing a lot of ECG images, and trying to detect all kind of the data points that is being changing all over the data, and trying to predict whether the person is going to have some kind of ailment in the cardiology or in any other part. So not only this, understanding cut detection, specifically in the cancer imaging. I also own a patent on cancers, brain tumors specifically. So my patent was something like this. I worked with some kind of government institutions and government medical college on that. So specifically in the CVs, what utilizing the computer vision on cancers is the most important thing that is happening right now in the industry, because There we are actually taking a human's face in input, and a computer vision algorithm is actually processing the face, and it is first creating a basic prediction line whether the person is having a chance of cancers or not. And when if it is confirmed there is a chance, then it is actually analyzing the brain images. If it is speaking about brain tumors, brain images, if it is a lung cancer, lung images, any kind of image, it is actually processing it and trying to find out which area is actually facing with cancers. So the cancer detection is really fastened up by the power of artificial intelligence. Another biggest example of CV I want to tell, like I have worked with a Japanese company called as a Medman. They were also working in this kind of the brain tumor detection, and that also had a very huge impact. Like they were actually predicting it very before time. So CV is a boom also in this kind of health IT. And apart from this, CV is specifically right now a boom for those who cannot speak, for those who cannot write. That means I'm speaking about Divyang, right? So I'm speaking about Divyang. Divyang is the most discussed topic right now in India and abroad. So Divyang is, we are speaking here about disabilities and the patients who are suffering from cognitive as well as some kind of genetic disorders. So the disabilities we all understand. Cognitive means the patients who are suffering from Parkinson's and Alzheimer's, right? You all who is listening to this session are like the future CV engineers or might be AI engineers right now as well. So when you will be creating the projects, this might be an amazing projects idea to you guys, like dealing with CV with the patients who cannot remember. What happens in Alzheimer's actually, patients actually cannot remember. They are completely blacked out about their previous life. They even forget how to eat. So we are dealing with that kind of patients, even the patients Parkinson's disease. So the patients who are actually suffering from nervous problems, like the body is entirely trembling. Okay, and when we speak about the genetic syndromes like Down syndrome, babies, many other, etc., etc., right? So CV is actually trying to create that kind of automated softwares on which we will today speak a lot. We are going to speak mostly about because prosthetics is here, right? Prosthetics is working with CV to help Divyang, to help disability person, right? So their CV is actually creating automated softwares that will give this kind of persons a fun. I have a short experience with a company again from Japan. Like they were actually creating an amazing new generation stuff. They were actually creating simple VR glass, but that VR glass is implied with natural language processing and computer vision. Let me tell you how. Let me tell you how. They were actually speaking about Alzheimer's patients. So what happens in Alzheimer's patient, they can't able to remember their previous memories. So what they are doing, they are letting the family members to tell their previous story, and the entire text or the voice is analyzed first with NLP, and then simply generated into or simply created complete vision in front of an eyes. Complete vision, that means something like a filmy stuff. Complete vision in front of the eyes by using computer vision, and that complete memory short clip is being shown in the VR glass. So what was the benefit out of that? The patient's nervous, like what happens in Alzheimer's, the nerves used to getting degraded. The nervous degradation rate get decreased slowly. So this is the new generation thing that Japan is doing right now. Mostly India will also adopt it very soon. So this is a huge experience in CV. Apart from this, if you speak about education industry, it's actually CV is coming for detecting cheating, for detecting fraud analysis. Everything CV is there, because itself in 2020 I had worked with MHRD India and IIT Bombay Meteorology Lab. So my project was in fact that kind of thing, creating AI based computer vision powered educational LMSs. The best part of the LMS was it was focused for the village students. What happens in the village students, or in general any student, I feel like, since what happens in this online lecture, interaction is very less. So a teacher can't be able to understand whether the student is understanding or not, right? So there we implied our CV powered algorithms that will actually analyze the human emotions and give a pop-up to the teacher, okay, please slow down your teaching rate. Like your student is can't able, your student can't able to understand the stuff, right? So these are the huge examples in the CV. Now come to the part of the problems in the industry. What are the problems in this at present industry? So the problems in this at present industry is actually three with the CVs. One is the detection systems. Like whenever we speak about security systems like security cameras, CCTV cameras, they are also for the automated technique CVs implied. What they do, they use facial recognition algorithm or person detection algorithm to prove like, okay, the person, like this person is a trespasser, this person is your employer, this person your home person, that's it. So they are trying to create an environment secure. But what happened if a person wears a face mask? The face is unknown to the CV and the CV is allowing to the person. Just for an example, if he wore a mask, that is a very big problem. So detection is not every time fine tuned, and most of the time a problem of noise come with the computer vision data. Noise, I mean, like the images are so blurry, the input video quality is so less. That means there is a lot of external noise in a data that create an actual mess, right? Specifically that comes under the detection systems. And for the security systems is all about changing the body structures, changing the face, changing the body movement, body angles. So what the criminals are actually targeting, like we see, like most protected banks are also getting looted up. So how it is? So specifically, the criminals actually target these loopholes of the CV industry. So they understand if I change my face at a high level, then the CV can't able to detect me and they will let me up. They will let me in. That's it. So this is the loopholes. So we will speak about that today also, but mostly is the biggest problem is the Divyang. What happens in the Divyang, like a thing that is being achieved by the CV is the multicolor treatment. What happens, like the uh, babies who are suffering from Parkinson's as well as the autism. Specifically, I want to speak about autism. Like simply the psychology proves, like they love to see their body or they love to see themselves into the multiple colors, because they love the colors and they want to play with their body with multiple colors. So there is a startup at Bombay, like they actually set it up a floor where they're actually creating CV algorithms to simply take an input image of these Divyang patients, and they're simply generating several type of the facial colors for them. So that is already a startup, but this is the thing that is being present. But we need more. We need to speak about those who don't have hand. We need to speak about those who can't speak. We need to speak about those who can't see, who can't hear, who don't have a leg. So everything comes under a Divyang. So the simple CV cannot deal. So these are the problems that we'll be speaking. So yeah, so now comes to like the how we can tackle this kind of stuff. So there are several types of the stuff being present in a CV. Like whenever we speak about the computer vision algorithms, we'll have a lot of models coming from the deep learning side. Even right now, the generative learning also came up. And apart from this, we all love OpenCV because the OpenCV is easily available thing, right? So apart from this, the CV is actually very vast. And a latest important thing to create some kind of the CV softwares. What happens when we create AI models? We need to have a huge processing power as well. We need to have a complete setup. But actually, right now, for the sake of TensorFlow launched TFJS. That means front end development for the TensorFlows developers or any kind of developers. That means front end for AI developers and machine learning for front end developers, the vice versa case. A framework is called TFJS. So most of the topics that today we will be speaking about will come under these two sections, OpenCV contours and TFJS, and everything will be in Python. So just coming to an example solution. So this, I want to speak about this problem specifically. So this problem, like it was the time of the COVID-19 at 2020. I had paid visit for the sake of my startup at very orphanage homes, like at many daycare homes, at many places. So what are the prime problems? Like again, the problem was like simply I want to speak about the autistic patients. So I've already told they love their face to be in the different colors. So I created a CV pipeline, simple small solution. That simple small solution was doing nothing. It was taking the input of the person's face. Like if you are a Divyang patient, you have to do nothing. Simply your caregiver will place a laptop in front of you and you have to simply pose in front of your camera. That's it. Immediately the camera will be taking the input of your face and it will be sending to a backend model we call to be as a Detectron 2 and DensePose. What happens in these two models? Specifically, DensePose creates some kind of masks on your body. That means DensePose is actually used to understand your body posture or understand your body structure, how much structure your body is actually having. That means what is your length of the body, how much region your body is actually actually being elevated, right? Everything, your complete body structure is actually extracted by the power of the CV algorithm that is called as a dense pose. And what does this detectron 2 helps? Detectron 2 helps in detection. That means detection means first it will analyze the person who is posing the camera, whether the person is a human or not. Whenever the detectron 2 will be telling like, okay, the person is the thing that is simply facing in front of the camera is a particular human, and simply detectron 2 will pass the data to the dense pose, and the dense pose will simply analyze the complete body structure of the particular person. Right now I made this project for only the face, but yeah, the same thing can be stuff for the all over body structure. So here we always introduce some kind of the contour detection. Now anyone one of you might ask why. So the contour detection will actually differentiate you from the external data. That means if you are seeing at my camera, like I am sitting and at my back end, a huge wall is there. So if I want only my figure, so I have to remove my background. So whenever we want to discriminate someone or discriminate something in between, we always have to understand what is the region of distribution. That thing is actually easily being implemented by OpenCV contours. And finally I created the software by using TFJS, TensorFlow.js. Nothing you have to do, you have to create a simple HTML code and you have to embed the TFJS model. That means you have to train the model and you have to store the model weight and pass to that particular HTML code, and this kind of the software is generated where I was simply posing in front of the camera and my multicolored face was generated completely. Anything I don't have to do, my complete 3D face was being extracted. And this is what we call as prosthetic vision. So what happens in prosthetic vision? Prosthetics speak about body structure, computer vision speak about analysis of the image and video. So this is a mixture of prosthetics and computer vision. So without my effort, it is generating complete 3D structure, 3D multicolor structure of my face, and which can move accordingly I want. That's it. So this is a very basic example of the solution. So see several types of the prosthetics CV example we can see over here. Like here is a game, football match is going on. If we want to know the body structures of the individual player, so where you have to use an algorithm that is called as a dense pose. I was speaking over here. So what is the dense pose is doing? Dense pose is only extracting the body geometry. Dense pose by the computer vision, artificial intelligence, it is extracting the body geometry of the players. That's it. Same thing for the above. Now, if you want to extract the complete 3D architecture or a complete 3D structure of that particular person, the same thing you can do with the same algorithm. So what things are actually saved up? The several kind of things is saved up. Like you no need to no need to use the ultra complex softwares like Blender, like several etc to do the 3D modeling. Only one computer vision algorithm embedded with prosthetics. That's it. You can do. So this is what is called as a new generation computer vision. So now let's speak about some more examples about prosthetics vision. Since prosthetics is like, these are all applications. Since prosthetics is like simply prosthetics, I have told mostly deal with the hardwares. So what right now the most of the industry is actually tackling and facing, like specifically I want to name about some example companies called as Nvidia, or like simply Intel. So just for an example, Philips, right, as well as the Sony Research Center India. Sony Research Center is doing a lot of work on robotics, prosthetics, and computer vision, situated at Bangalore. So specifically, what they are doing, they are actually targeting the patients who don't have hand, who don't speak, who don't see, who don't hear, who don't have any kind of legs. So they are actually creating an arm called as a prosthetic arm. So how does this prosthetic arms are being controlled? So here you have to understand simply some kind of the comparisons with an existing state of art. Like before the so much of the development in the CV, like before we are so much developed in CV, like or so much being developed in the field of the artificial intelligence. What was there? We can create the arms. We can create the simple arms. Like we can create simple robotics arm by using servo motors, by simply embedding a code in the Arduino or Raspberry Pi. We can do that kind of stuff, and we will be simply inputting some kind of the commands. By the sake of the motors attached, the arm can move easily. That was an existing state of art. Now what CV is doing? So what CV is doing, like if you just picking an example of a Tesla autopilot, it is also utilizing computer vision. So what does Tesla autopilot do? Just many of you might be interested, how can a Tesla autopilot understand the red light? That means a red light I need to stop, or how can a Tesla autopilot can understand a zebra crossing, or how can a Tesla autopilot can understand a traffic. These all are the examples of an object detection stuff. That means the Tesla autopilot's algorithm, that means at the back end of that particular car, by powered through some kind of AI cameras, they're actually taking the input of the real-time road data and they're processing it to the computer vision algorithm, and they're running a object detection stuff that is actually speaking some kind of traffic is in front of you. That's it. So same thing we do in the prosthetics. Just for an example, this is a person who lost their hands. Specifically, you have connected Arduino, you have connected processors, processing unit, everything you have connected. Now what role will CV will actually play? There are several types of the prosthetics arm available. So one thing is there are actually three type of the prosthetic arms. One is the gesture controlled, another is brain controlled, and the last brain or the mind controlled, and the last but not the least is the ECG controlled. So here we are speaking about gesture control. So prosthetic, this actually is taking the data from your optic nerve. So what your CV algorithm is doing over here, it's actually tracking your eye. Just for an example, you are moving your eye on that side, your prosthetic arm will understand the person will want to pick any object from that side, right? If you are moving your eye to the right to left, it will simply move the arm accordingly to the right to left. This is an eye tracking algorithm. So a very famous eye tracking algorithm being commonly used is called as a gaze detection. Gaze detection is one of the most common computer vision algorithm being used over there for tracking the eyeballs and the eye kind of the stuffs, right? So it is based on your position of the eye and the facial movement. It is simply speaking, it is simply speaking like, okay, hey, move the prosthetic arm from that side to this side and this side to this side. Now many of you might ask, so how can this eye tracking kind of stuff is being understood by the CV? So this is a high level architecture or a high level technology is being used over here. Not so much high level. Only you need to do this. If you want to do this project at your college level, one you have to need a processor, you have to need an Arduino, you have to need a thermal camera, and that's it. You have to connect the flow, and that's it. Okay, and you have to make this arm only prosthetic arms. That's it. So how you can do? You have to place the camera in front of your eyes in your particular spectacles. The camera will be collecting the data. That means it will understand in which direction your face is moving. So immediately when the camera will be collecting the data, it will send the same data to the processor. Apart from this, if you have a high budget, you can simply apply that kind of stuff that is called as the brain band. So the brain bands, what the brain bands used to do, I guess you guys know, the heart used to give ECG and the brains used to give EEG. They both are the electrical signals. Okay. So what the brain band used to do, a brain band is easily available in the market. It's quite expensive, but if you are dealing with some kind of the high budget stuff or any kind of a high budget project, you can simply afford it, right? For a research project specifically. So if you can also attach some kind of the brain band. Brain band will be completely collecting the brain data. So what the brain is thinking will be simply converted into some kind of electrical signals. Now these both signals will be coming to the processing unit, and in the processing unit we are actually applying object detection and the gesture detection CV algorithms. Now the CV algorithms is processing the data and giving you an output and passing the output to the Arduino, and simply Arduino is controlling the prosthetic arms. So this is how the prosthetics innovations is working. After this innovation of prosthetic arms, specifically it have a huge effect on armies. Like most of the time in the wars, like the army personnel lose their hands, like simply they lost their legs. So this is a huge example for them. So this is a detailed diagram of the prosthetic architectures, though it is actually connected with ECG. Previous example was an example of EEG, brain controlled and gesture controlled. This one is actually an example of ECG control. So specifically what happens when you have one hand right and another hand you lost. Suppose you have one hand right and another hand you lost. So ECG is another the signals that is generated from the body, that is the heart, right? So to move this type of prosthetic arms, you have to simply stiff one hand or give a pressure to your body through one hand. So when a pressure will be felt, some kind of the vibrations will be generated through the ECG and again will be passing to the control system, the computer vision models we are passing. It will be applying a model of pressure detection. It is completely a numerical detection model, pressure detection, and it will be moving your hand accordingly. High pressure left, low pressure down. So this is an example of an ECG controlled prosthetic arms. So this is another visual example of a prosthetic hands. So it is, you can easily 3D print this kind of hands. So believe me, specifically this kind of hands can help you easily in a smooth picking of an objects. Like not only smooth picking in an objects, right now Nvidia introduced a complete stuff by the brain band. A single person only sitting in a chair, thinking about the action, immediately the data signal comes to the processing unit and the action detection model works by computer vision. And immediately computer vision model works and it tends the data to the Raspberry Pi, since Nvidia used the Pi models, Raspberry Pi, and simply the hand is actually moving. So how we move our hand as per we think, so the same thing is actually coming into dominance. So it is completely a mimic of a human architecture, right? So this is an example of a prosthetic arms. So apart from the prosthetic arms, same type of an examples are available for prosthetic legs as well as the prosthetic organs, but this is not right now in the productions, but prosthetic legs and the hands are being there. And mostly like in within some years we are going to have prosthetic eyes as well. Like if you lost your eye, don't worry, simply buy a prosthetic powered computer vision eye and we will be having a surgery and attaching with your nervous system. That's it, that will helping you to see. So just a very basic example of the prosthetics are prosthetic eyes are here, that is called as the prosthetic glasses. So what this prosthetic glasses is actually doing, just for an example, you lost your vision, you cannot see. So the cortex of the human brain is actually dealing with that kind of optic nerves, right? So what the engineers are right now doing, they are simply attaching some kind of electrode chip with that particular cortex. So whenever the person will think I want to see, the data will be transferred to the cortex with the prosthetic vision glasses. Immediately the processor will learn and a complete visual will be being shown through the glasses to that particular person. So this is a very big thing that is coming within 22 and 23 through US. I don't know when it come in India, but 22 and 23 US is actually launching it. So it is a complete wireless network connection for those who cannot see, and they will be seeing the stuff by the power of computer vision. So let's see some examples. This is a very basic example of a prosthetic arm. This person is, this is actually a video being generated by the Bloomberg with the power of Nvidia. Nvidia provided the Nvidia trained their models with a power of 100 supercomputers for this particular thing. And this person is actually thinking how to control my hand, and immediately the hand is getting controlled. This is another an example, like this is another an example being specifically generated for Divyangs. So I already told specifically Divyang who are suffering from Parkinson's, autisms, they love to see their body in multiple colors, in multiple ways, in the multiple vision, right? So this kind of a thing, simply generating the 3D architectures by using prosthetic models and simply giving a motion into it. Now you might ask, how can I add motion to a particular still 3D image? So specifically for that in computer vision right now we have generative learning. So this is another boom in the industry where a computer vision have the power, or a deep learning models have the power to generate their own stuff, generative adversarial neural networks. So what we are doing, we are actually adding lives to the non-living objects. That's it. So this is all about a very basic stuff about how computer vision is scaling up prosthetics, how prosthetics is helping, and how we can improve security systems, how we can improve or help the persons who are having the disabled. So yeah, so thank you so much. Open to queries. If you have any kind of queries, feel free to connect with me. Also, I will be speaking at PyCon 2021 India this year. You can also join. There my talk is also a deep dive into prosthetics by power of AI/ML. So you can also join over there. So thank you so much. Open to queries. If you have any queries, feel free to ask. Okay, if you have any kind of queries, feel free to ask. Yeah. Yeah, hi.
Hi, hi. Let's give them some time to if they are asking something or like. Till then, you can share your experience. Like, how is it going? Like
Yeah, specifically, if anyone wants to come in the field of AI/ML, they can kickstart with understanding the stuffs in Python. Like, firstly, they have to keep a hold on Pi, and after just having a hold on Pi, they have a monthly planner of 2 to 3 months. Like, yeah, like firstly understanding and implementing the ML models, and then just scaling up to ML model to OpenCV, understand the theoretical sections. After when you complete out the ML algorithms, 12 ML algorithms, and OpenCV, you can simply come up with the deep learning kind of the stuffs. So there is a question: how computer vision can help to deal with schizophrenia? Yeah, schizophrenia, hallucinations. So specifically, right now, what
actually,
is
there is some connection error, or actually, your voice is not clear. Hello.
is my voice clear right now?
No, it's cut.
Just a second. Is it clear right now?
Yeah, yeah, perfect. So we have a query like Dablina Meti, how computer vision can help to deal with schizophrenia.
Schizophrenia. So specifically, what happens in the schizophrenia is all about the hallucinations, right? Like I am sitting in this particular place. No one is speaking about myself, but no one in the room is speaking about myself. But I am still feeling someone is speaking about myself. So this is all about the schizophrenia. So schizophrenia is actually a psychological disorder, and that deals with also that kind of the hormonal changes that we call as a dopamine, adrenaline counts. So specifically, actually, prosthetics doesn't comes in the schizophrenia, but yeah, computer vision actually there are researches been going on in the US sections that like if someone is having some kind of the hallucinations, then we can inbuild some kind of the
Again, cut.
chips in the cortex section. Is it
Hmm.
clear? Is it properly coming, or still there is some
Hmm.
kind of lag? Yeah. So feeding some kind of the chips, that means the AI embed chips. Right now we have the chips that controls. We have that kind of the chips that control. That is not into productions, but we have chip that controls the hormonal imbalances. But that hormonal imbalances is actually controlled with the like understanding of the hormonal imbalances doesn't come from the computer vision. It comes from the detection stuff. So the chip is actually understanding the chemical reactions of that particular chip with the body, and they understand first what hormonal count the body is having. Accordingly, they release some kind of extra stuff that will be balancing the level. But this everything is not into production. Everything is a research. A lot of research papers is coming, dealing with schizophrenias, dealing with depressions specifically. So specifically, right now, computer vision doesn't have a lot of thing for schizophrenia, but yeah, researchers are being there. But yeah, there is a chip being launched by Nvidia, or I don't know, I guess GE. I don't know who launched a chip, but there is a chip I know that equally works for the schizophrenic or the psychological patients as well as for the Alzheimer's patients. Will it be possible to build AI consciousness in a
Yeah, we.
uh, digitalized structures of artificial intelligence? Yeah, actually it is possible, but digitalized structures in an artificial intelligence, like what is the main problem for dealing or creating the digitalized structures by using the power of AI models is all about the processing. So what is the problem with the AI CV processing? Actually, like working with this 3 years with CV, like mainly the CV algorithms have a problem with the data processing. That means it needs a lot of processing powers. It need to have a lot of like processing strength, CPU, GPU powers. And whenever we try to give it, we need to have a strong server strength. We need to have a strong DB understanding strength. We need to have a strong not only the server and not only the DB, as well as the processors that we are actually using, and which comes with a higher cost. So that kind of cost affecting stuff is there. So that, for an example, the peoples are not a lot of thing, like they're not investing a lot of money in creating digitalized consciousness. But digital consciousness is there. Digital consciousness is being used by AI just for a dream analysis. Specifically, dream analysis stops, dream analysis models is being there. But that's also the same stuff. If you are having any dream, you have to wake up in a morning and you have to tell, and simply your data will be simply stored, and through NLP, through text, it will be converted into videos, and that videos will be passed to the CV, and through computer vision trained models, it will be simply analyzing what kind of the dream you are having. Apart from this, the people are working, specifically some kind of the us scientists in the Silicon Valley. They're actually trying to incorporate CV with our brain death kind of mechanisms, but still it is not in a success. So that's all. Any other query?
Guys, I would like to request you that feedback form will be shared in the chat box. Please fill this out for your certificates.
Okay, so I guess there is no other
So,
query.
hmm. Okay, so I would like to take the charge of vote of thanks. It's my privilege to propose a vote of thanks on the event of prosthetics and new generation computer vision. I, Piyush Kashyap, on behalf of Engineers Connect and the entire fraternity team of management here, extend very heartily gratitude to the speaker for gracing your crucial work and sharing your knowledge with us today. The participants were very enthusiastic, and I am thankful to them for coming over here and attend the session. We are fortunate to have one of the eminent person like Anustup Mukherjee as our expert speaker. I'm sure that the participants will be benefited by joining us in this webinar. I am very much thankful to the Engineers Connect family and especially to Sir Bhushan Gaikwad, and who constantly giving me this all the time support for doing this. I extend my sincere thanks to all the team members of event organizing department at Engineers Connect. An event of this dimension can't happen without the team support and needs meticulous planning and execution in the detail. I would like to thank one and all whose involvement showed the willingness they have performed to express the completion of the work beyond their comfort zone. Thank you very much. Stay home, stay safe, be strong. Follow the COVID-19 guidelines by government strictly. I have shared the feedback form in the chat box. Please fill that for your completion or for your certificates purpose, and you will be receiving the certificates within 3 working days. So please do not make the constant queries for this, because once you have done the feedback thing, you will definitely will be getting the certificates. Okay, thank you, Anustup. Nice meeting you. Bye bye. Thank you, guys.